This is Algebra 2 with Trig, working with Unit G, which is a geometry unit. This is day number 4. When we talk about our trig ratios, we're talking about using Sohcahtoa to help us remember what those trig ratios are. So the sine of an angle is going to be opposite over hypotenuse. It's a little dark for you, I imagine. The cosine is adjacent over hypotenuse. And tangent is the opposite over adjacent. So those are the trig functions used to help calculate for missing sides, and we would use the inverses to help solve for missing angles. Find the area of a triangle. Well, this is going to be a multiple step equation or problem because we have to take half the base times the height for the area of a triangle. We have the height. The height and the base have to be perpendicular to each other. So we're going to have to first figure out x, which is your base, and then we're going to plug it into the area formula. So we know the opposite side, and we know the adjacent side. So what trig function are we going to use? We're going to use tangent of 32 degrees equals the opposite over the adjacent. Put it over 1 and cross multiply. So x times the tangent of 32. Then we're going to need to divide to get the x by itself. So the tangent of 32 has to come on over. You need to be sure you're in degree mode. Sine of 30 degrees should be 0.5. That'll show you if you're in degree mode or not. You would have to, in mode, you got to be sure you're highlighted in degree if you're using a graphic calculator. So we did 11 divided by the cosine of 32. And that should give you 17.6. So we're going to round to the nearest hundredth, so that would be 60. But really, we only want to round our final answer. You never want to round work in the problem. So now your area is half the base times the height. We're going to write down 17.60, and our height is 11. But when I do my calculation, it's always best to use previously calculated work. So we're at a half. You can use 1 divided by 2, or you can use 0.5 since it's the exact value, times our previous answer. That's our 17.603697988182. And we're going to times that by 11. So it looks like our area is going to be 96.82 if we're rounding to hundredths. We didn't round early. We didn't round our work in our calculation. We used the answer value. And we don't have specific units, so we'll just call this units squared. So that's our value of the area of a triangle. You have to know base times the height, divided by 2. Now we're going to find the perimeter. The perimeter is the distance all the way around. Well, we know we have one side. We have to find the two other sides. So to find x, Across is called the opposite side. Next to, the leg next to the angle, is the adjacent side. So that's going to be tangent again, because opposite and adjacent of 61 is going to be 22 divided by x. Now when x is on the bottom, we saw before that we essentially switched the x and the tangent of 32. So we're going to switch those around. Just help speed it up a little bit, but I'm still showing work and how I got my values. So the 22 divided by the tangent of 61 is 12.19. Now we have to come up with our other missing side. You can either use trigonometry or you could use Pythagorean Theorem. Since we have to use exact values anyway, it might be best just to talk about the opposite and the hypotenuse. So that's going to be sine of 61 equals the opposite over the hypotenuse. Well, we'd switch those. So the hypotenuse equals 22 divided by sine of 61. So our hypotenuse is going to be 25.15. So we know that the hypotenuse is supposed to be the longest side. So 25 is longer than 22. And the two legs have to add up to be greater than the 25. And 12 and 25, or 12 and 22 clearly add up more than 25. Perimeter is going to be the three sides added together. So our perimeter is going to be 22, 12.19, and 25.15. If you want to be sure to use the exact values, then you can say 22 plus, and with the graphing calculator, you can go up to that 12.19. And you can go up to the 25. And that will bring them down by hitting enter on them. You entered in the exact values. But either way you do it, here we would round this to 35.35. Let's see what would happen if we used the numbers that they gave us without being exact. Here we got a 13.34, but it's the thousandth spot that added up to do a little bit more rounding. So it's best to use the exact values. These would be units, since we don't have a specific unit to use. Not unit squared, just units. It's not area, it's length, it's the perimeter. Now this is your chance. Find the area and the perimeter of the triangle. Round your final answer to the nearest hundredth, but don't round early. Go ahead, pause the video, give this one a try, then come back and watch it. So if this is 56, for us to find area, we need the perpendicular sides. So we need to find this side, which would be the opposite, and this would be the adjacent. So that's going to be tangent. I don't want to get too close to the hypotenuse. So the tangent of 56 equals the opposite over the adjacent. Now notice I wouldn't switch those. There'd be no need to switch those. I need to multiply those. When you put it over 1, you end up multiplying those. So 13 times the tangent of 56 equals x. 13 times the tangent of 56 equals 19.27. So that's the approximated value. We'd probably call this the base, if you would like. Doesn't matter. The area is going to equal half the base times the height. We'll take 0.5 times the previous number. So we use the real value and the extra piece to give us an area of 125.28 units squared. These are square units because it is area. Now we know what the x value is. We've got 2 of the 3 sides. For us to figure out perimeter, we have to calculate the hypotenuse. So the hypotenuse would be adjacent over hypotenuse, which is cosine. So the hypotenuse is going to switch with the cosine of 56. Rather than multiply, then divide. We're here together anyway. So we have 13 divided by the cosine of 56. We get 23/25. So that's the length of the hypotenuse. So if we were going to add them all together to figure out the perimeter is 13 plus approximately 19.27 plus approximately 23.25. 13 plus the 19, we'll take that answer, plus we'll take the 23 number. So we're adding those all together. We get 55.52. And those are units. Okay. Here we have a rope. It's staked 20 feet from the base of a building. So there's our building. We have some windows on our building. We have it staked 20 feet from the building at an angle of 58 degrees with the ground. "20 feet from the building." How long is the rope? If the building's standing straight up, we would consider the unknown the hypotenuse. So this is the adjacent and the hypotenuse. So we're going to use the cosine of 58 to equal the adjacent over the hypotenuse. We will switch those. Cosine of 58, do 20 divided by the cosine of 58, and that gives us 37.74. And that's the length of the rope, and the rope was in feet. The units of the problem were in feet. Nearest tenth. So if we were to do tenths, that would be 37.7 feet. When we're doing story problems, there's a common term called angle of depression. That's when you're up high and you start to look down from a horizontal. Compared to looking straight out, you're looking down, not straight down, but you're looking at an angle downwards. That's the angle of depression. When you're on the ground and you look straight, that's horizontal, so the angle of elevation is looking up. Your angle is always based off the horizontal line, never off the vertical line. These two angles are going to be congruent with each other. They are alternate interior. They make the zigzag. They will be congruent. It depends where you want to draw your triangle when you're making the figure for the problem. If you look up at an object, the angle your line of sight makes with the horizontal line is called the angle of elevation. The other one is if you look down at an object, the angle your line of sight makes with the horizontal is called the angle of depression. Always remember that the angle of elevation and angle of depression are measured from the horizontal, from the horizontal line. Before attacking these problems, let's draw a picture. You want to be sure that you can represent and understand exactly what you're trying to calculate. Don't just visualize it, draw it. A pilot is looking at an airport from her plane. So we're way up here. We got our airplane, right? We're looking down at the angle. The angle of depression is 29. So where is our angle? From our horizontal line looking straight out, 29 would be that angle right there, 29 degrees. If the plane is at an altitude of 10,000 feet, so you could use 10,000 here, but then 29 is not in that triangle. You could also use 10,000 here, and the 29 is inside that triangle. How far from the airport? How far is x? So we're looking at the opposite side. We're looking at the hypotenuse. That is the trigonometry ratio of sine. Opposite over hypotenuse. We're going to switch the x and the sine of 29. So we take our 10,000 and we divide that by the sine of 29. And we're getting 20,626. Not 26, but 20,626.65, and these are units in feet. A dog is looking at a squirrel at the top of a tree. The distance between the two animals is 55 feet. So you need to understand what that distance would be. It's not from the ground up, perpendicular, but the distance between the two can be slanted. It's not how tall the tree, it's not how high up in the air the squirrel is, but it's the distance between the two. And the dog is down here. Just fun little tail and his mark. Okay. 64-degree angle. How high is the squirrel? And how far from the base of the tree? So we need to know the height, and we need to know the x value to the tree. So you've got to be able to draw the figure to give yourself a visual of what you have to find. We're looking at the opposite side and the hypotenuse. We're looking at the adjacent and the hypotenuse. The sine of your 64 equals the opposite over your hypotenuse. When we put 1 underneath it and cross multiply, we get 55 times the sine of 64. Notice we did not switch anything because we don't have our variable on the bottom of the fraction. So 55 times the sine of 64 gives us 49.43. And those are feet, and that's how high up in the tree the squirrel is. How tall the tree is if the squirrel's at the top of the tree. And then how far from the tree are we? So that's adjacent over hypotenuse. So that's using cosine. Again, when we cross multiply, we won't be switching any of the numbers. The x stays put. We multiply the 55 times the cosine of 64. That gives us 24.11. And those are also in feet. So you can pause the video, work through the example number 2 and example number 3, and then turn it back on and check out your answers. A lamppost is 11 feet tall. So we have a lamppost, it's got a light on the top. If the angle of elevation through the top of the lamppost to the sun is 49 degrees, approximately how far is the top of the lamppost I said sun. What the heck? A lamppost is 11 feet tall if the angle of elevation of the top of the lamppost. Oh, gotcha. Okay. So the sun is coming down this way. The sun is right here. It's like a flagpole, but we're going to do flagpole later. So this is a lamppost, something up high. We've already done a tree question. So we've got a lamppost. It might not be blaring bright out, but since the sun's out, we got a shadow. The angle of elevation to the top of the lamppost is 49 degrees. How far is the top of the lamppost from the tip of the shadow? How far is that? It is 11 feet high, remember. So opposite and hypotenuse. So we are going to do sine of 49 equals the opposite over hypotenuse. Because the variable is on bottom, we can cross or switch them. You can cross multiply if you want. You can bring that up there, and then you have to divide by the sine of 49. You're right back down here. So we have 11 divided by the sine of 49 gives us 14.58 feet. We know the hypotenuse is going to be longer than the leg of a right triangle. So that's reasonable that we could get 14. Find the height of the flagpole to the nearest foot. We look out, it's probably some sort of shadow at 65 degrees. So opposite over adjacent. Notice I label my triangle every time. So that's going to be tangent of 65 equals the opposite over the adjacent. Notice that the variable is on top. There's nothing to switch. We're just going to cross multiply and multiply those two together. So we get 24 times the tangent of 65. We get 51/47. And those are in feet again. And last question. The road rises 10 feet in a horizontal distance of 200. So over 200 feet of horizontal distance, the road is going up 10 feet. What is the angle of incline, or what is the angle of elevation? I put a theta symbol in there. That is our angle that we're trying to calculate for. So we look at the opposite, we look at the adjacent. We're not looking for the hypotenuse. So we're going to use tangent of our angle is going to equal 10 over 200. If you would like to call that 1 over 20, that would be fine. So the measurement of our theta angle is going to be tangent inverse of 10 over 200. So tangent inverse of 10 divided by 200. So our measurement of our angle is 2.86 degrees. All right, good luck, everybody.